Hello, Mr. Natural here in Golden Gate Park again, near the greenhouse. Um, Today I'd like to continue on where I left off with senses. We were, to sum it up, talking about the five senses are biologically engineered. They are not engineered by people. People do things a little different. They are basically motor senses. That means they only pick up or receive information as long as what they're perceiving is showing differences or is in motion or doing something that's has to do with movement. They're not passive in nature, they're active in nature. And this causes some problems. One of the first problems are hallucinations and delusions. We have to understand that the five senses that we have are not objectively accurate. They tend to be subjective in nature, and they do serve a logical imperative, and that is survival. The senses were designed and made to help the species continue to exist and to survive. So they do not tend to be as objective as we would not want them to be objective, because there's a lot of things that have to do with the flight and the fear responses that they need to trigger in order for the being to survive. We've been talking about the eyes as being little hands that reach out and grab the photons and pull them into the mechanism, and I'm putting a link in the description box below to a TED conference by, I guess the guy's name is Beau, Lotto, and he shows a lot about visual senses, why we use color and not black and white, and what are the advantages to color. But this brings up an issue. If I look at the color green and you look at the color green and someone else looks at the color green, are we actually seeing the same color green, or have we agreed on something based on linguistic convention? And I believe it has to do with linguistic convention, because there is so much that's involved in just seeing. One of the reasons we use color, for instance, instead of seeing things in black and white, is it helps us find predators. If you had a black panther, which is one of the examples that Beau shows, hiding, and all we could see was black and white, it'd be easy for the panther to hide amongst the trees and pounce down on us and kill us. But the fact that we see color allows us to see the green leaves, the brown tree, and the black panther, and it helps us in our survival. The senses do a lot of things. They create a lot of optical illusions, and therefore inside the brain, the symbolic models that are being created tend towards delusional, and they cannot be counted on. They're not objective. So let's take some simple examples. If we're looking at something, for instance, Fred was mentioning in one of his videos on beauty that he was looking at a tree, and then some birds flew by, and he noticed that no matter how focused or interested he was in the tree, as soon as the birds began to enter the peripheral vision, his attention was diverted towards the birds. That's because the birds are moving, and relative to the background, there's constant differences happening, Since the motor senses are what we call operational amplifiers, and they work as differential inputs, differential amplifiers. Differential amplifiers are designed specifically to eliminate noise or get rid of anything which are coming on to two inputs that are the same, and they only pick up the differences between things. It's why they're so wonderful to use them as audio amplifiers for eliminating the background noise coming from your guitar plugs and the hums and buzzes and things like that, which happen on both channels equally, are completely eliminated. This priority for motion is really an evolutionary advantage, again, for us to be able to get the hell out of there if something's going wrong. And things that we notice that are steady state do tend to disappear on us, and we have to divert our attention to look back to have them reappear. Some of the things that affect this, as Beau will point out, are In the case of color, say 3 people looking at the color green and deciding linguistically that they're all looking at green, and being able to go to a box of crayons and pick out the same green. There are lots of things that influence the decision of what green is green. That is, one, the light that's falling on it. Any colored light falling on it will change the green from what it is objectively to what we're seeing subjectively. The color of the atmosphere itself, the air between us and what we're visualizing will tint. Usually here in San Francisco it gets foggy, so I'm used to things having a gray cast upon them. Also emotionally, if we are damaged or we're upset and our body produces a lot of adrenaline, what happens is the visual cortex moves or shifts towards the blue end of the spectrum, and we see a lot of yellow. Or red, the blood flow in the eye will cause the atmosphere to be tinted and put a red cast upon things. So when you're scared, quite often things turn yellowish. When you've been running a lot and you stop for a moment, you look at things, the blood flow in the eye is greater and tends to tint things red or purple. The other thing is, and this is probably the context around something. For instance, if I take a green square and place it on a black background, that could be a pretty dark green, and it will look very, very light with the black background. If I take a bright color green and put it on a white background, it will actually look darker than it is. And he starts his lecture at the TED conference by showing, getting people to pick reds and greens and oranges and see some are on black backgrounds, some are on white backgrounds, to see if you can tell the difference, and then moves them over to show you what the difference is. Some of the things he doesn't point out is, I think everybody is familiar with the cube, where you draw on a blackboard a picture of a cube, you 2 squares, and then you connect them so they look like a cube. And although they are flat on the blackboard, our mind has learned to develop since the time of Da Vinci. Artists started taking paintings which were essentially flat and had learned the concept of perspective, which was a learned thing. It is not innate to the species. And what happened is, as people started working with pinhole cameras and started looking through small pinholes at art, or started drawing grids on artwork so it could be reproduced in different sizes, changing the scaling, they became very familiar with the notion of perspective. And so perspective really is a mathematical attitude that has developed in the brain over a period of time. Also good for hunting and fishing, to get your line in the right place to catch the fish. But more so in art, it sets up ambiguity. With a 2-dimensional cube drawn on a board, you have to decide which face is towards you and which face is away from you. And the interesting thing, when you look at something like that, if you decide that the face that's to the right is in the back, it will look back, and the left side face will come towards you. But if you suddenly change your mind and you decide it's the other way around, lo and behold, your eyes will accommodate, the vision will accommodate your attitude, and the 2 sections will change, and the cube on the left, the square on the left, will move to the background, and the cube on the right will suddenly move to the foreground. And by changing your mind, you can keep moving the cube back and forth, the 2 faces back and forth, and decide either one is the back and either one is the front. And here is a case where the visual cortex is satisfying the notion or the idea of what it is we expect to see, what we want to see. Beau also shows, one of my favorite things in there is he takes a 3-dimensional shape, which is basically a bunch of wire, and he rotates it, and then you look at the shadow of it rotating, and you ask yourself, is it rotating left or is it rotating right? And the interesting thing is, when you look at the shadow, if you decide it's going clockwise, you will see it turn clockwise. But if you blink your eyes and open them again, it will reverse and go in the other direction. And if you blink your eyes and open them again, it will reverse and go in the other direction. And every time you blink your eyes, it will automatically turn around and go in the other direction. Again, we're taking a three-dimensional thing, projecting it onto a flat surface, and then the whole notion of it being three-dimensional is basically a notion. And depending on how we modify that notion, the attitude that we have about it determines what it is we see. There's another great optical hallucination that he does not show, and that is people forget that in the center of the eye, where the very center of the retina is, there are not light receptors in the area. There's actually a hole in everyone's vision. And yet right now, as we're watching this, you don't see or perceive the hole. And there's an experiment you can do where you can set a person on a chair, let's say that's holding an umbrella or holding a stick at the height of their chest. And then what happened is, right where their head is at, if you move your vision over and find a spot on the wall, and then move your head forward or backwards, there'll be a point in which their head actually disappears. You'll see a headless body there, because you will get the dark, or the area where there are no receptors, the spot lined up. And if the person's not moving at all, what will happen is their head will just disappear because it's hitting the black spot in the eye, what they call the blind area, or the blind spot. And then what happens is, if you keep focusing at that thing, if they take that umbrella or that stick, an interesting thing is even though you're seeing the person without a head, if they move the stick up and they move the stick down, you will actually see the stick move up above where there is no head and back down where there is no head, and you will actually see the stick moving in the area where you still are not perceiving the head. So the motion of the stick is causing the imagination to fill in, to tell a story, and to fill in that blind spot, because it's in motion. And even though there is a head there, you still will not perceive the head. You will only perceive the stick moving up and down through the area. Of course, the minute you turn your eyes away or you pull back from that, the head reappears. So it's a fact that every moment of every day, there are two blind spots in both eyes which are being filled in by the imagination. And again, anything that is in motion moving through the spot has a higher priority, and anything that is in steady state has a lower priority. And it is possible to create this hallucination in which the head disappears, and yet you can move the stick up and down and you will see the stick moving, but you will not see the head. It's a very common optical illusion. So this brings up the whole idea again that the model that the brain is creating of the world outside really is flawed information, and that our intent can modify this. The story that we want to hear, the story that we want to see, can be modified. So when 3 or 4 people are looking at the color green, we may linguistically learn to agree on what we call green, and they might actually be seeing 4 different shades of green. But because of the linguistic attachment to whatever it is they're experiencing, they're able to pick the same color green out of a box of green crayons. Now, when we use passive systems, for instance, in photo-optic devices, we can create passive systems that measure the frequency of the color much more accurately. And of course, with those, we have their accuracies of up to 16 million shades of color, even though the visual cortex is exactly 1 octave wide, and the rainbow, the 7 colors of the rainbow are made from 3 primary colors, which create the 7 hues or main colors of the rainbow. In between all those colors, within that 1 octave, that can be divided down into approximately 16 million colors. And although the eye is capable of seeing quite a few little changes or shading differences, it still subjectively can be modified so much that we cannot objectively say such and such is such a color. So we have developed passive systems as meters, which are extensions of the eye, meters which are extensions of the taste and of the smell and of the touch. And we developed things like telescopes and microscopes that allow us to look or extend our vision on a microcosmic or macrocosmic scale. And we've moved from looking through the microscopes with our eyes to putting some type of an optical device on there. We can take this optical device, which is passive, we can set it up in a particular state of being, and then any slight changes in that state can be measured. So we can measure the frequencies of these colors out there much more objectively, and we can use the numbers that we gather from our instruments as a means for saying what is true or what is not true. So although we cannot rely on our senses, our mind is capable of designing and building passive systems which are much more accurate. And the eye, or the visual cortex, simply becomes a model for designing other types of devices which extend its range to the microcosmic, so we can see tiny little things like little amoeboids and viruses and things floating around inside and learn about biological science. Or we can extend it with telescopes like the Hubble telescope and look into the deepest parts of space, 13.7 billion light years away, and find the very edges of our own universe. And we can trust or rely on the objectivity of those numbers that are coming from the passive systems, but we cannot rely on the visual cortex itself. I find it actually liberating as an artist. The left brain of me objects to the fact that I have to constantly scrutinize the input from my senses and remind myself that illusion and delusion is the norm, and that my intent can shadow what I'm seeing, and that other factors can enter in to change what it is I think I'm perceiving. In court, it's been known for a long time that eyewitnesses are not necessarily reliable. 3 people can see the same crime and will give testimony to seeing 3 different events. So what happens is the adrenaline that they're receiving, the attitudes they have about things, the perspective, the point of view that they have, where they're seeing it from, all these things change what they're viewing. And so even eyewitnesses are not considered that credible. So my left brain objects to the fact that I can't rely on these things, but my right brain, the artist in me who creates beauty, who spends time working with these ideas of approximations and inconsistencies and delusion, the part of me that likes to create illusion and delusion for entertainment purposes, loves it. And I really have to use both sides of my brain. My left brain and my right brain have to work together. I have to use the pragmatic part of my brain to hone and polish and work my art into something. But what I'm going to use is my right brain influences, the approximates, the fuzzy variables and fuzzy sets that it produces in order to create this beauty in this art, a lot of which I know are also based on survival instinct. But hey, you know, we have 5 senses. They're fun to use. We should use them. We shouldn't trust that they're that objective. We should understand that a lot of modification and a lot of storytelling goes on inside of our own heads, and that our idea of what we think we see and what we think we're perceiving is really us telling ourselves our story about who we are and what we are and where we are in this whole chain of this food chain of things that are going on here. And I, as a Gestaltist who believes in both the right and the left brain and realizes that the right and the left brain are perceiving reality from 2 totally different world viewpoints. The right brain being an inductive machine that goes from the general to the specific, the left brain being a deductive or digital machine which goes from the specific towards the inductive. I can live with that. I like to use that. I feel the art that I want to create. I think about the emotions I want to create. I think about the story I'm going to make up, and then I use my left brain to gather together the resources that I need to pull together the symbols and the objects that I'm going to use to weave together into the story so I can create the optical and hallucinatory experience for you as an artist. I can use it to tell my story. So it's gotten pretty dark now, and we'll talk more about this later. I want to talk next time about what I was talking about, eigenvalues. What's really out there? What do we know about the frequencies that make up it, which is outside the head, and realize that a lot of what's going on inside the head is my story, your story, and the world and the life that we're experiencing is really going on inside of our own cranium. And we all have a right to be wrong, and we all have a right to see, view, tell, and live our own story. We have a right to have opinions about it, but we must understand that they're our opinions, and they're not necessarily other people's experiences or other people's opinions. And frankly, I feel that people who are very left-brain have a point, and I agree with them, and people who are extremely right-brain have a point, and I agree with them, and I am constantly trying to gestalt the two into a single mind. The two brains work together as a single mind, and anytime they're split, they will act as if they are their own mind, and even through a volition, even through fear, I can split my own mind up into as many little pieces as I want and become as schizophrenic or as delusional or as multiple personality disorder as I want to be. See?